Hello Math 8 students, this is Open Up Resources Unit 1, Lesson 17, Rotate and Tessellate. To get started, you will either need to print off a page that I have saved in Canvas, or you will need to do this digitally. So before I even go over any of the lesson, I'm going to show you what I'm expecting you to do. You have options. So here is Canvas. Here is the lesson that you are watching this video in. And right at the beginning I say your teacher will give you some shapes. That means you need to print this page. When you click on that link, it will open this document with these shapes. Now you only need to cut out one set of shapes after you print them. If you cut out both, it might actually make the job a little bit easier, but it's not required. So either print and cut out, or the other option is to open up this PowerPoint document so that you can do everything digitally. If you're opening up this PowerPoint document, this is what it should look like. Now I am actually going to open it incognito because I'm already logged in, and so when I open it, it's already going to let me start editing it. So I'm going to open it incognito so that it shows the same experience of what you're going to be doing. You are just going to click. You don't need to open incognito, you just need to click. So when I open it incognito, this is basically the same sort of screen that you're going to be seeing, even though you just click on it. And it says it's read only. It's because I don't want you to make any changes to it because it's my document. But if you save it in your own drive, then you can make those changes. So you don't have permission to edit this file. I understand that. But we're going to go File. We're going to go Download As. And we're going to download a copy. Don't download a PDF because you will not be able to edit it. But if you download a copy onto your computer or into your OneDrive, it will allow you to make those changes. So I click Download. I'm going to go ahead and open that up. And it's opening up over here. Now I have access to edit it. This is because we downloaded it now. Now it's asking permission to actually enable the editing, making sure that it's a safe file. So enable editing, and now you can make those changes and you don't need to print off the document that I gave you. So the choice is yours. Do you want to do it more tactilely using your hands, or do you just want to manipulate these shapes virtually? I'll let you be the judge after I go through this video explaining and showing how it's going to be done. You're going to notice that I have color-coded these copies. So when you print it, it is not color-coded. You don't have to, but it is going to make the job a little bit easier. Even if you don't have multiple colors, as I have used here, if all you're doing is just marking them like A, B, C, D, that will still do the job. We just want to be able to differentiate one angle in the shape from all of the other angles. Now, let's get down to business. The first thing that we are asked to do says, how many copies of an equilateral triangle can you fit together around a single vertex so that the triangle's edges have no gaps, no overlaps? So I'm going to start by placing a vertex. Now, whether you're manipulating these in the PowerPoint document or you're just manipulating them the way that I am here in this folder, the process is still going to be exactly the same. So I'll show you one here in my notebook file, and then I'll show you one in the PowerPoint, and you'll see just how similar they are. So now I can take this and move it over, and notice what I'm really doing is I'm lining up this blue angle, and so I'm trying to figure out how many of those we can fit in there. So I'm going to have to rotate it. Rotated it now. I can see that I'm forming another triangle, and both of those angles are sharing that vertex. We're building all of these triangles around that single point. I'm going to get another one up there, and I could just place it here, but I want us to practice for some of these other more complicated shapes of lining up the same angle. So I'm rotating it so that that blue angle is there. Looks like I've got 3 so far. Let's keep on doing this. If you printed these, then what you're going to be doing is each time I set it down like I did just there, you're going to want to trace that on your own paper. So you trace it on your own paper, and then you would move your shape into the new position. So again, this is me moving that into the new position, my cutout shape, and I'm dropping it here in this place, and once I drop it, that's when you're going to be tracing it. So in a certain way, doing this digitally is a little bit less work because you're not having to actually trace them because you keep on just getting new shapes. Looks like I can fit one more. So again, I'm just trying to line these all up so that it's always that blue angle that I'm trying to line up there. And that's what it means when it says, how many copies of the equilateral triangle can we fit together around a single vertex? We kept going around and around and around this single vertex until I was all the way done. And you can see that in doing that, I now have created a full 360-degree angle. And that 360-degree angle is made by 1, 2, 3, 4, 5, 6 of these smaller angles. So what is the measure of each angle in the triangles? We're going to use that information that this is 360 degrees, but I'm splitting it into these 6 pieces, or that 360 degrees is made up of these 6 pieces. And so that tells me 360 divided by 6 is equal to 60 degrees. That means each one of these little blue angles is 60 degrees. Well, what about the other angles? Now, since this is an equilateral triangle, we have talked about this before, that means that all of the angles are also going to be the same. To prove it, I'm going to take one of these, rotate it, and you're going to see that even if I have to move it back into position, you're going to see that that green angle fits in there perfectly. And if I wanted to rotate it again to the yellow angle, again, I might need to move it, but you'll see that that yellow angle fits in there perfectly. So that kind of verifies and confirms that all of these angles in this equilateral triangle are the same. They are 60 degrees. So we answered that question there, 60 degrees. Now what about all of these other shapes? What we're doing is we're going to repeat that process, and ultimately I want to know, what are the measures of all of these angles? What are the measures of the angles in a square? What are the measures of the angles in a hexagon? And so on and so forth. So I want to be able to do that, and the way to answer those questions is to repeat that process, but for each of these different shapes. If you continue to build these shapes around a single vertex, you'll be able to identify how many it takes to get to that full 360, and then use that to work backwards to figure out what one of those angles is going to be. Let me show you what it's going to look like if you are using the PowerPoint. Again, it's very, very, very much the same. So I'm going to be building around a blue, or around a vertex. I don't have the ability in PowerPoint to put in that point. I could, but it's not quite as nice. But I'm still repeating that process like you saw on the notebook file, where again, I'm just kind of rotating them into place and trying to squish them together. You can see I'm forming around the blue edge here. I'm going to get another one into place. Continuing to build it around just like I did before. They still rotate in very much the same way as they did in the notebook file. These ones you just get to manipulate yourself. Looks like I over-rotated, gonna correct that. And the last one. Okay. And if you're building these, if at any point you run out of shapes, I've usually included enough, but if you've run out of any of those shapes, it's just a simple just copy and paste, and you'll get you another one on there if you need that. So if you're using that PowerPoint file, it's going to work the same as what I'm doing here in my notebook file. So I'm going to use the notebook file. It's going to work the same for you. With that in mind, we ultimately want to answer all of these questions. What are the angles in each one? Pause the video so that you can use that PowerPoint file and answer that question. You can see I've got a new page for square, a new page for hexagon, for the parallelogram, which is also a rhombus, for the right triangle, the octagon, and the pentagon. So I've got a new page for each one. There should be enough of these shapes to be able to build that circle and figure out those angles. So I do want you to take the time to do that. What I suggest is maybe do it with one. So just start with the square, then watch the square part of the video. Then you try it with the hexagon, then watch the hexagon part of the video, and so on. So you do one and then watch that part of the video. That way you're not going and doing all of them and possibly making a mistake and then continuing that mistake again and again and again instead of getting it corrected. So pause the video, work on the next one, which is a square. And this is what it would look like. I'm bringing my squares out. I'm going to build it around here, so I'm going to use just those yellow angles. And hopefully you already know how, what the degree of the angles in a square are. But this exercise will also help to confirm that. So again, I'm just building all of my yellow angles, see how they're all there together. And I can see that when I do that, I have 360 degrees. But it's made up of 1, 2, 3, 4 angles. So 360 divided by 4 is equal to that 90 degrees. So this yellow angle here is 90 degrees. Just like we thought it was going to be, it is a square. But what happens if I rotate this? Does it work for a green? Notice that that green angle rotates perfectly into place, which tells me that green angle is also 90 degrees. And that blue angle rotates perfectly into place. It is also 90 degrees. And so is this pink angle. They're all 90 degrees. So all of the angles in the square are 90 degrees. All right, you get a try now. What about the hexagon? How many angles, or what is the measure of the angle in the hexagon? Your turn, you do it on your own, then return to the video and see how it works. Okay, let's take a look at the hexagon. I'm going to go ahead and build around the green one this time, getting some new shapes on there. Rotating it, trying to match up greens there. Doing it again. And yeah, we can see that that fits nicely into place, but I just want to be precise. Let's just focus on just that green angle, and it looks like I was able to build that full 360 degrees, no gaps, no overlaps, and I can make that full 360 degrees using 3 of these green angles. So that tells me that that 360 split 3 ways is equal to 120 degrees. So at least this green angle is 120 degrees. What about the blue angle? Notice that when I rotate it into place, it does rotate perfectly. What if I rotated this one? Let's just compare all of those blue angles. Rotating all of those into place, and it looks like all of those blue angles will do the same thing. Those blue angles will all form 360 degrees when there's 3 of them. And again, you can continue to do this, but I hope that you just observe I can rotate that pink angle into place. Maybe I have to move the figure a little bit, but it is rotating perfectly into place. And so we can see that all of these angles in the hexagon are all going to be that same 120 degrees. The white angle fits in there perfectly. This orange or tan angle fits in there perfectly. And back to yellow, we can see that they all work so beautifully. So let's write that one down too. The hexagon, each one of those angles is 120 degrees. Parallelogram, which one are we talking about? We're talking about this one here. This is the parallelogram. So pause the video, you give it a try. After you've given it a try, then come back and watch the video. Make sure you've done it correctly. Okay, this one we do have to be careful because I want you to observe that there are 2 different angles in this parallelogram or this rhombus. Do you notice that that pink angle is different than the blue angle? Even trying to stack them up on top, we can see that they're different. And so we got to approach this 2 different ways. I'm going to focus first just on the blue one. So now I'm building around blue. Going to rotate those all into place, trying to build at least a full circle using just those blue angles. All right, and it looks like I probably over-rotated just a few of these. Hopefully you believe me when I tell you that we used 6 of them to go that full 360 degrees. So 360 now split 6 ways is equal to, once again, 60 degrees. But that's not the only angle. We already pointed out that that blue angle is different than the pink. So I'm going to repeat this process again, now looking for that pink angle. All right, and again, it looks like mine are just slightly off, but I hope that it's close enough for you to observe that, again, I can go that full 360 degrees using just these 3 pieces now. So 360 divided by 3 is 120 degrees. So this pink angle here is 120 degrees, and this blue angle here is 60 degrees. So how much are the other angles? And again, observe, Instead of having to repeat that whole entire process, I can just rotate this and see, oh, look at yellow angle fits in there perfectly, so the yellow angle is going to be the same. And similar here, I can rotate that one and see that that green angle fits in there perfectly, so that green angle is going to be the same as the pink angle. And so we have a 120 degrees here, and that yellow is 60 degrees. Again, let's go back and write that down. Parallelogram, we had a 120 degree angle and we had a 60 degree angle. Now for the right triangle. You'll want to repeat that process because again, when I'm looking at this right triangle, I can see there's different angles. So I'm going to have to repeat that a couple of times to find all of the angles in that right triangle. So here's our right triangle. Go ahead and pause the video, give it a try on your own. See if you can find both yellow and pink and blue, find all of those angles. All right, hopefully you've given it a try. Here's yellow angle. This one's the easy one because it is called a right triangle. So hopefully it's easy to see and understand that since it's a right triangle, we're going to have one of these angles being 90 degrees, which of course happens when I have all four of those forming that circle. So I have the full 360 degrees split into those four triangles. 1, 2, 3, 4 triangles is how we get there. So it makes sense that that is 90 degrees because it is a right triangle. But let's repeat that process now. I'm going to let you choose pink or blue. Building around pink, maybe you chose blue. It's tedious, but honestly, if you're doing it digitally, it's a little bit easier digitally than it is trying to trace these all by hand. Almost done. All right, now I was able to form that full 360 degrees again. This time, however, it took 1, 2, 3, 4, 5, 6, 7, 8. So that 360 split 8 ways is equal to 45 degrees. Now, I'm not actually going to flip those around and use that blue angle because I want you to remember some of those important properties that we just learned about and finished up in our last unit. There are 180 degrees when I add up all of the angles in a triangle. So I have 90 and 45. What does that final one have to be? Knowing that 90 plus 45 plus that blue angle has to be equal to 180. 90 and 45 add up to 135. So that means I would subtract the 135 from 180. And I get B, the blue angle, is equal to 45 degrees. So let's write that one down as well. In our right triangle, we had 90 degrees. We're not surprised because it said right triangle. So 90 degrees, and the others were 45 and 45. Okay, now is where we have some fun. Now it's time for the octagon. Give it a try. Pause the video, you try it on your own first. Once you think you know, then you can come back. All right, let's go orange angle this time. Orange angle, trying to line it up here with orange angle. I'm gonna go grab this orange angle, rotate it into place, and you can see we've got a little bit of a problem here. Yes, I can make a full circle, but I make a little bit more. There's some overlap this time, so I can't use 3 octagons because 3 octagons is too much. It goes past that 360 degrees. So we've got an issue here where I've got this much here, and I haven't completed that 360 degrees. I've got this much more to go. How much more is that? Hopefully it looks familiar. Looks like something that we just saw. I can use one of the angles that I already know. See how it slides in there perfectly? I already know this yellow angle is 90 degrees. So when I'm now completing that whole entire circle using all of those shapes, I now have 360 degrees, but I have 360 degrees because I have these two angles plus this extra 90 degree angle. So let's get rid of that extra 90 degree angle. The 360 minus the 90 is 270 degrees. So that tells me that these two angles here together formed that 270 degrees. And again, it took two angles to do that. So the 270 divided by 2 is 135 degrees. So this orange angle here is 135 degrees. Well, what about the rest of those angles? Let's rotate it into that cyan, that blue color there, cyan. And it looks like that fits in there perfectly. So that cyan is going to be 135. What if I go to pink? That fits in there perfectly, 135. What about white? Fits in there perfectly, so that's going to be that 135. So I think it's safe to assume that every one of those angles in the octagon is going to be the same. Let's return to that page and write it down. Octagon, they're made up of those 135 degree angles. And now we're really going to have some fun. Pentagon. Look at this pentagon first. Notice there are 5 angles. We need to find all 5 of them. So that means we're going to have to repeat this process here with Pentagon 5 different times. Pause the video, see if you can find all 5 angles, and then we'll come back. Going to work on getting orange angle first. Orange angle. So I'm rotating these so that I'm only using orange angle, trying to form that circle with just orange angle. Because if I'm using the same angle and I get to that 360, I know I can do that 360 divided by how many times I use that angle. So here it looks like orange angle took 4 of them. So 360 divided by 4 is, we've seen that before, that's 90 degrees. So this one here is 90 degrees. Now I'm going to repeat that here with cyan. Okay, and it looks like with cyan, 360 degrees. Using 4 cyan angles means that each of those cyan angles is also 90 degrees. Let's repeat using yellow now. Well, how about that? Looks like we have another 90 degree angle. Again, forming that full 360 degrees using 4 yellow angles. So 360 divided by 4 is equal to 90 degrees. So we know yellow is 90, cyan is 90, and orange is 90 degrees. Now's the fun time. Let's find pink and green. We'll get started here with pink. Trying to form this with just those pink angles. All right, how about that? Pink angle. We formed the full 360 degrees using just 3 pink angles. So 360 divided by 3 is equal to 120 degrees. Pink angle here is 120 degrees. And now for the fun one, green. Trying to form that 360 using just green. And you're going to notice I can't use a third green because we're going to have that same problem that we had with the octagon, that it's overlapping. Yes, I make the full 360, but I'm reusing some of that. I'm using even more. So, if only I had a shape that would fit right here, whose measure I already know. We do. And that is our equilateral triangle that is going to fit in there perfectly. Even if your triangle sticks out, that's okay. We're not worried about the lengths. We're just worried about that angle. So we already know that this angle here is 60. I was able to get some of that 360 using those two green angles. The rest of the 360 came from right here. So the 360, let's get rid of that 60-degree angle that we used from the triangle, and that gets me to 300 degrees. That 300 degrees was obtained by using those two green angles. So that 300 divided by 2 is 150 degrees. So green angle is 150. Let's go ahead and mark that down. All the way back to the beginning. Pentagon, we had a 150-degree angle. We had a 120-degree angle. And we had 3 90-degree angles in our pentagon. Okay, that's it for today. This lesson was just heavy on the rotation aspect because I really want us to start looking at, if I'm trying to make something with no gaps in it and no overlaps, what kinds of things do I need to be looking for? And so we found some really nice measures of angles that we can use, and we are going to save the rest of this for our next video because this lesson did take 2 days in class, so we're going to save the rest of it for the next video. If you have saved this digital document, that's going to be really helpful because what we're going to be working on next time is this last page in it. So just hold on to that file and we will continue this the next time. That's it. We'll see you next time.